A couple of jobs I've been doing recently have required me to turn a couple of fairly long tapers. I made this years ago and the component parts are quite simple. The 2 Morse taper to fit the method, I mean you could turn that up using the cross slide, but actually looking at it, I've recovered this taper part from a presumably defunct Tailstock drill chuck or something. I mean, because that's clearly a bolt part. This body is either brass or gunmetal, but it doesn't need to be. That would be as well steel. I've clearly used this because somewhere in my box of junk I found an appropriate piece of I don't know what it is, brass, bronze, who can say, out of which to make that, but it would be as easy to make it out of steel, probably a lot cheaper if you had to buy it. And I've used I've got dovetails in the end of that, which you can see, and then machined up a steel block to slide in that dovetail, and there is a jib strip in there as well, which is tightened with these screws. And when I set the thing over, I actually tighten these screws down, which has the effect of locking the slide in whatever position I've decided I need. Because I can't remember and can't find the article and drawings from which I made this offset tailstock adjuster, or whatever you call it, I thought I'd take it apart and just show the constituent parts. I rather wish I hadn't, because it took me nearly an hour to do, because I couldn't remember how to take it apart either, but never mind. The main body consists of a 2 Morse taper arbor to go in the tailstock of the ML7 Super 7. The main body, I've used a dovetail cutter to cut these ways, into which I've also machined and cut the adjuster itself, I suppose that's what you call it, so that one goes into the other. The jib strip's not in at the moment, it's here, so hence a bit of play, but the one slides in the other. All homemade. That's out of a block of steel. I don't know that any of the dimensions are particularly critical. The adjusting screw is threaded 3/16 by 40, and that fits into this bit of 7/16 steel block, and I'll just show how that works. There is a slot machined in the top slide part of this device, which fits over this. Obviously you can't do it at the moment because that's in there, but that slides along and fits over it, and then that slides and is held captive by this lock, something like that. There you go. And the final part is to just drop the 3/8 peg in the end, which is quite a decent fit. That could be Loctite in really, and that's the part that holds the ball bearing, which I use to support the end of the centre. Actually, it's become a bit loose. I think I might just put a bit of thread lock on that. There it is then. A bit of not set yet. A bit of thread lock on that. Stop it wobbling about. Might Loctite it actually. because this doesn't actually need to be removed really, but all assembled. This adjustment wheel doesn't really work. It should have been knurled. I can't get a grip on it. But what I mostly do actually is, what size is this? 7mm socket, and I just use that to wind it in and out as far as I need to. Seems to work well enough. And the way this works, of course, is that you simply adjust this to create an offset so that the work won't be parallel to the bed anymore. And there's an adjusting screw around the back here somewhere. I'll take it off the lathe in a minute where you do that, and I put a couple of graduation marks on here just for reference. So you adjust it across by whatever mechanism to find whatever taper it is you think you're playing with. And I've got a variety of different size ball bearings, which with a dab of grease just put a ball bearing in this end so it don't fall out. It really is the only function of the grease while you set things up in order to run the part. So in this case I've been turning a taper on this column, and obviously you need some sort of driving dog arrangement, which I'll show that separately. And the ball bearing is just running in the centre at this end so that you can turn, and that works very well. If I had the 3-jaw fitted to this end, I also made this little thing here, so that is turned true and fits in the 3-jaw, and creates a ball bearing between centres at the other end, and I have used that occasionally. Just for the moment I couldn't be bothered to take the 4-jaw off, and decided it would be easier to dial it in and do it that way. And does it work? Well, I'm feeding in 0.002 at a time, and yeah, seems to be alright. In this example I'm using the Tailstock set over device to taper turn two ends of a connecting rod to give a fish-bellied appearance. The overall length of the rod's about 6.5 inches and it's quite slender, but it seems okay.